In today's class, I am discussing about a problem on a cantilever beam with a uniformly distributed load. Okay, so look at the problem which is in my note. A cantilever beam AB 2 meter long carries a uniformly distributed load of 1.5 kilonewton per meter over a length of 1.6 meter from the free end. Draw the shear force and bending moment diagram for the beam. So here the length L or span or length L of the beam equal to 2 meter. Here the UDL is along 1.6 meter, that is it is not to the total length, on the total length. Okay, it is up to 1.6 meter length from the free end. So total length equal to the total length of the beam is 2 meter, but the total length of the UDL is 1.6 meter. UDL W equal to 1.5 kN per meter, and length of the cantilever CB carrying load equal to 1.6 meter. Let it is as A. Okay, now draw the figure. The load UDL is starting from the point B to the point C, where CB equal to 1.6 meter. The UDL is 1.5 kN per meter. So the figure A is cantilever beam. The total length equal to 2 meter. Now at first we have to calculate the shear force. So shear force at B, that is FB equal to 0, as I have discussed in the theory. At the end point there is the load is just starting, so there is actually no load acting, so FB equal to 0, and FC equal to, as according to theory, equal to W into A equal to, here length of the cantilever CB may put as A equal to 1.6 meter. A means the up to the length where the load is acting. So W into A, W is load, so equal to plus 1.5, W is 1.5, W is 1.5 per unit length, into length is 1.6, so plus 2.4 kN. It is the FC, and FA equal to FA would be equal to FC, because up to this the load is acting, and there is no extra load in point A, but the effect of as the load we are considering the load from right to left, so the effect of total load is also acting or present in point A, so FA equal to also 2.4 kN. Now the for calculation of bending moment, at first MB equal to 0, at the load is just starting from B, and the distance of B to B is 0, so MB equal to 0, as according to theory. MC equal to minus WS square by 2 according to theory. You can see the theory, equal to minus 1.5. here A is 1.6, so 1.6 square by 2. Why 2? Because we are taking the midpoint, the distance of midpoint of the total load, and as we may assume that the total load usually is acting at a point who may be or assume as the CV of the total load or total length. So this is equal to minus 1.92 kN m, and MA equal to, it would be obviously minus. The all the forces for shear forces will be positive as the right downward, and all the negative, all the bending moment will be negative as hogging moment. Now what is hello MA? MA equal to, look at 1.5 into 1.6, 0.4 plus 1.6 by 2. Okay, as according to theory, you can see that